Hello everyone, welcome to lecture number 13, which we are going to talk about the flip-flops. And first we are going to introduce the flip-flops by introducing the basics, and then we will learn what is the clock pulse and how does it work. And then there are some other pins which are called enable, preset and reset. We are going to learn them as well. And then we've got four different types of the flip-flops. One of them is SR, D, JK, and T flip-flop, and the function of each of them is different. So we are going to learn those kind of flip-flops as well. So the flip-flops are synchronous bistable devices. So when you say bistable, that means they can have only 0 or 1 at any given time, or 0 or 1. And then the term synchronous means that before the flip-flops, which is a sequential logic circuit, we had the combinational logic circuits like the logic gates, and we had multiplexers, decoders, encoders. Whenever you apply an input, let's say you have a NOT gate, when the input is 1, the output is going to be 0 directly, and when the input is 1, the output is going to when the input is 0, the output is going to be 1 directly, or the input is 1, the output is going to be 0. So that is a direct transition from the input of the output. The output changes as soon as the input changes. But the term synchronous means in the flip-flops, we have the inputs and the outputs, but they are not going to be changed simultaneously. Is the output changes at only a specific point when a clock pulse is applied. So we are going to learn what is clock pulse. And so this clock pulse is going to be given to the flip-flops through an edge triggered flip-flop. So that means sometimes the edge triggering may be positive edge, raising edge, or that means when the clock pulse is 1, and sometimes it may be negative edge. So that means the clock pulse is going to be 0. So these are some types of the flip-flops. Just learn them. We are going to cover each of them in detail. For example, this is an SR flip-flop. It has two inputs, SR, and it has two outputs, Q and Q complement. The Q is the normal output, and the Q complement is the opposite of the Q, or the complement of the Q. The Q is 1, the complement of the Q is going to be 0. And here we've got D flip-flop, which has only one input, and it has two outputs and a clock pulse. So that means this output changes based on this input whenever this clock pulse is applied. So this is positive edge, but this one is negative edge. That means when the clock pulse is 1, the output changes according to the input. Then we are going to learn this relation between the output and the input as well. But in this case, the output changes based on the input whenever the clock pulse is 0. So if the clock pulse is not applied, and we are going to change the input anytime, the output doesn't change because the clock pulse hasn't applied. But if the clock pulse applied, the output changes according to the input. So this D is input, but this is a clock pulse, and this S and R are inputs, but this C is the clock pulse. So here the clock pulse, for example, changes from 1 to 0. So that means in this case that the output changes when the clock pulse is negative edge or is 0. But in this case, when we don't have the bubble or the NOT gate there, the output changes when the input is going from the 0 to 1. So that means the clock pulse is in the state of 1. So we may have a series of clock pulses. For example, in this case we have 0, but this is positive edge. That means it goes to the positive side, or to 1. This is negative edge, positive edge, negative edge, positive edge. But the output changes based on the input when the clock is, in this case, whenever we have the positive triggered flip-flop, and the output changes according to the input when the clock pulse is 0, or in this state if we have a negative edge triggered flip-flop. So in some cases we may have more than those inputs, S and R clock, Q and Q dash. We may have preset, or we may have clear. So what is the function of each of them? When the preset is 1, the Q is always 1 regardless the S or R. It doesn't depend on the S or R. The preset is, when the preset is 1, the output is always 1. Okay, in this case as well, in that case as well. And When the clear is 1, the output is always 0, regardless the S and R or the D or the J and K or the T, the other side of the flip-flop. In those cases as well. When the clear is 1, the output is going to be 0. That means this flip-flop is cleared. And when preset is 1, that means this flip-flop is preset. It doesn't depend on the inputs. It's always 1, okay? So to summarize flip-flops, let's say we have this flip-flop. We have that input and that input, which are the normal inputs. We may have preset and we may have clear. And we always have a clock input. This is the clock. And we always have two outputs, which is the Q, the normal output, and the complement of the Q. When the Q is 1, the Q complement is 0. When this is 0, and the Q complement is going to be 1. And sometimes we may have enable input. This enables the flip-flop. If enable is 1, that means this flip-flop is working normally. The output changes based on the input whenever the clock pulse is applied. But when enable is 0, anytime when you change the output and when you apply the clock pulse, the flip-flop is not working, okay? So this is an SR flip-flop. You are going to learn it. This is the picture of the SR or the block diagram of the SR flip-flop. This is S, this is R, and this is Q, and this is Q complement. You see the Q complement is opposite of the Q. And this is the clock pulse. Look, you see this is a positive edge. That means the output changes according to the input whenever the clock pulse is applied. Okay, so that means in this case, the output changes based on the input. So let's say we have S and R and we have the clock pulse as well. And we have the output. So it has 4 stages. When S and R, both of them are 0, the output is not changed. That means it doesn't change. The output is not going to be changed. It's going to be the same as the previous output. Okay. When S is 0, R is 1, the output is going to be 0. When S is 1 and R is 0, the output is going to be 1. And in this case, it is invalid in SR flip-flop. So the flip-flop is not working when both of the inputs are 1. And the clock pulse must be applied. Then this functionality works, or the output gets a function or gets some triggering function or changes or whatever is going to happen according to those based on the inputs, and this must be applied the clock pulse. So it has those 4 states, while this one is invalid and that one is not changed. That means the output remains as the previous input, as the previous output, sorry. And in those states, the output is going to be according to S. So if S is 0, the output is 0. F is 1, the output is 1. Look, you see, the S is 1 and the R is 0. Whenever the clock pulse is applied, the Q goes from 0 to 1. In this case, the S is 0 and the output, the R is 1. The clock pulse is applied here. The output goes to 0. Why? Because the S is 0. So in this case, when the S is 0 and the R is 0, that means we have no change. This Q, this output, is going to be the same as the previous output. So the previous output was 1 or 0 is not going to be changed. It's going to be the same as the previous one. Look, this example makes it more clear. This is the clock pulse. We have positive edge. That means it changes in this case, that case, that case, that case. When it goes from 0 to 1, 0 to 1, 0 to 1, 0 to 1. So in the first case, in here, the S is 0 and the R is 0. Okay, so what happens here? It's going to be not. So this is the solution. We can see it. So at the beginning, the output was 0. The Q is 0. So in this clock pulse, the S is 0, R is 0, so the output is going to be no change. It remains 0. This one was 0 and this one is going to be 0 as well. Look at in this case, the S is 0 and the R is 1. So whenever the S is 0 and R is 1, the output is going to be 0. In this case, in this clock pulse, the S is 1 and the R is 0. That means whenever the S is 1 and the R is 0, the output is going to be 1. And in this case, it's going to come back to 0 because the S is 0. Look, in that case, the S is 1, the R is 0, so the output is going to be 1. And in this clock pulse, the S is 1, the R is 0, so the output is going to be 1 as well. So this is the opposite of the output of the. And we have D flip-flop. D flip-flop is only a special case of the SR flip-flop, and it's called data flip-flop. It has only one input. This is D. and this is Q bar and the clock pulse. So this is going to be taken from the SR. So the D is directly connected to S and the opposite of the D is connected to R. That means whenever the D is 0, the S is 0 and the R is 1. Whenever the D is 1, the S is 1, the R is 0, right? So if D is 1 and the clock pulse is applied, the output is going to be 1. Why? Because 1 is connected to S and 0 is connected to R. And in this case, in the SR flip-flop, the output is going to be 1. So don't care about that. In D flip-flop, when D is 1 and the clock pulse is applied, the output is going to be 1. Whenever the D is 0, the clock pulse is applied, the output is going to be 0. So this is the positive edge. That means this one, in this case, the output going to be gets a function or gets be changed or stuff like that based on the inputs. So we have only one input. So the clock pulse is applied and the input is 1, the output is going to be 1. The clock pulse is applied here, the input is 0, the output is going to be 0. The clock pulse is applied, the input is 1, the output is going to be 1. And the clock pulse is applied, the input is 0, the output is going to be 0. So the third type of the flip-flops is JK flip-flop. And JK flip-flop is mostly the same as the SR flip-flop. It has no change in 0, 0, and is going to be, the output is going to be 1 whenever the J is 1 and the K is 0. The output is going to be 0 whenever the J is 0 and the K is 1. And in the SR, we saw that when both S and R are 1, the flip-flop was in invalid state. But in this case, whenever we have JK flip-flop, whenever both of the inputs are 1, the output is going to be toggled, or it's going to be the opposite of the previous one. So if the previous output was 0, this output is going to be 1 whenever the J and K are both 1. And you must consider that the clock pulse must be applied. Look, this is the truth table. Both of them are 0, the output is going to be no change. 0, 1 is going to be 0. 1, 0, the output is going to be 1. Whenever we have 1, 1, the output is going to be opposite of the previous output. You can see it in this example. Okay, that's great. Look, we have negative edge. Look, that is very important. That means the flip-flop, the output of the flip-flop gets function when the clock pulse goes from 1 to 0. Okay? But if it was positive edge without this one, it got function whenever it goes from 0 to 1. So in this case, J is 1, K is 1. Look, the first output is 0 before doing anything. So when it comes to this flip-flop, J is 1, K is 1. That means toggle. That means the output is going to be the opposite of the previous input, the previous output. The previous output was 0. So this output is going to be 1 because in this clock pulse, both J and K are 1. In this case, both of them are 0. That means no change. The output is going to be the same as the previous output. So the previous output was 1 and this output is going to be 1 as well. So in this clock pulse in here, the J is 0 and the K is 1. So the output is going to be 0 because the J is 0. And in this case, the J is 1 and the K is 0. The output is going to be 1 because whenever they are different, the output is going to be the same as the J. And in this clock pulse as well, the J is 1 and the K is 0, the output is going to be 1. And this is the explanation of that. And we have this example as well. We have positive edge. That means the output is going to be changed or going to be set or reset based on the inputs in those cases, whenever the clock pulse goes from 0 to 1. So in this case, the J is 0 and the K is 0, the output is going to be remained unchanged, or it's going to be no change as the previous one. But in this case, whenever it goes to 1, the J is 1 and the K is 1, so it's going to be toggle. The previous one was 0 and this one is going to be 1. In this case, J is 0, K is 1, so the output is going to be 0. In this case, J is 1, K is 0, the output is going to be 1. In this case, J is 1, K is 0, the output is going to be 1. In this case, J is 1, K is 1, that means toggle. The previous output was 1, so this one is going to be 0. So in this case, the J is 0, the K is 1, the output is going to be 0. And the last type of the flip-flops is called T flip-flop. T flip-flop is sometimes named as toggle. It has only two states. This is derived from the JK flip-flop. When T is 1, both J and K's are going to be 1. So that means the flip-flop is in toggle state. When the T is 0, both of them are going to be 0. That means it's going to be in no change state. So this is the T flip-flop. So when the T is 0 and the clock pulse is applied, the output is going to be no change. And when the T is 1, the clock pulse is applied, the output is going to be toggled. And here is a small example. If the previous output is 0, this is the next output. Okay. And the T is 0, the output is going to be no change. So this one is going to be the same as this one. And when the T is 1, the previous output was 0, this output is going to be 1, because when the T flip-flop is 1, the output is toggled. It's going to be the opposite of the previous one. In this case, when the T is 0 and the previous one was 1, so it's going to be no change. And when the T is 1 and the previous one was 1, so that means it's toggle, the output is going to be 0. And this is the wave diagram. If you have positive S, that means it gets function in those cases. So the previous output was 0 at the beginning. By default, it is 0. So the T is connected to high. That means in all of the clock pulses, the flip-flop is going to be toggled. So the previous was 1 and the previous was 0. And when this clock pulse is applied, the T is 1, the output is going to be toggled. In this clock pulse, also the T is high or 1, the output is toggled. In all of the clock pulses, the output is going to be toggled or opposite of the previous